Our next topic is the unit circle, which will be the most important part of the rest of this unit. If you do not understand the unit circle, you will struggle with everything else that we're going to do for this unit and the next unit. So please make sure any questions that you have get clarified about this topic before moving on. A unit circle is simply a circle with a radius of 1. The reason that is so helpful is because if we think about those 6 trig functions, dropping in a right triangle here, the hypotenuse is the radius of the circle, which is 1. So sine of theta would be opposite, which is our y value, over 1, or the y coordinate of any point on the unit circle. Cosine would be adjacent, which is x, over hypotenuse, which is 1. Tangent would be opposite over adjacent. And then, of course, we have our reciprocal functions. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. I think I had that extra triangle drawn down there so I could enlarge what I just showed you. So I will do that for you in case that picture was a little bit too tiny. So theta, there's that angle right at the origin of our coordinate plane. Of course, our x-coordinate is what moves side to side, and our y-coordinate is the vertical. Hypotenuse on a unit circle is the radius, which is 1. Our essential question, and I can't emphasize that enough, is how does the unit circle work? First thing we're going to do is use it to evaluate those 6 trig functions again. Remember, the unit circle has a hypotenuse of 1, so sine, which would be opposite, which is our y value, over 1, the y-coordinate of this point is negative 5/13. Cosine would be adjacent, or the x value, over 1, or 12/13. Tangent, remember, was opposite over adjacent, which is our y-coordinate over our x-coordinate. So we've got a little bit of simplifying to do on this one. So y divided by x, meaning multiplied by the reciprocal of x. Those 13s cancel, we get negative 5/12. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. What I'm going to do for you next is generate all of the points on the unit circle, the ordered pairs that you will need to memorize the sine and cosine values for, as well as tangent. However, if my version doesn't make sense to you, here's another resource. You can watch another teacher generate the unit circle for you if you need some extra clarification. So coming up, you will have a unit circle quiz. You will be given a blank unit circle and you'll be asked to generate all of the values that I'm about to generate for you now. So make sure you understand exactly what I'm doing and ask questions if I lose you anywhere. First of all, we'll need to know all of the angles in degrees. The angles that we will memorize are actually related to those special right triangles that you may remember from geometry. There were 2 types of special right triangles, the 45-45-90 and the 30-60-90. So our first one is 30 degrees, and then we have 45 degrees and 60 degrees. The first quadrant is the most important quadrant in the unit circle because you can then use patterns to reflect those values into the other quadrants. So I'm first going to generate the first quadrant, and then I'll show you the patterns and how I generate all of the rest of the unit circle. In radians, we have pi over 6, pi over 4, and pi over 3. So again, one way to remember how these radians link to the degrees, 30 degrees is pi over 6, 60 degrees is pi over 3. They swap. If you think about fractions, it does make sense because pi over 6 is a smaller fraction than pi over 3. And then the 45 degrees goes with pi over 4. So hopefully that one will be a little easier to remember. Ordered pairs, again, these are coming from special right triangle relationships as well. So the first ordered pair on our unit circle is root 3 over 2, 1/2. Then we have root 2 over 2, root 2 over 2. The 45-45-90 had those 2 sides that were the same. And then the 60 degrees flips from the 30 degrees. So it's 1/2 root 3 over 2. Next, we'll go through the points that are on each axis. So our first one, of course, is either 0 degrees, or a full rotation would be 360 degrees, up at 90 degrees, over to 180 degrees, down to 270 degrees. And we already did that full rotation. In radians, we would have 0 or 2 pi, up at pi over 2, over to pi, and down to 3 pi over 2. Those ordered pairs, we're going the full length of the radius out and not up at all. Then we're going the full length of the radius up, but we didn't go over at all. Over at pi, we'd be at -1, 0. And down, we would be at 0, -1. All right, getting those degrees in the other quadrants. So the 60 degrees reflects over another 60 degrees to 120 degrees. 90 plus 45 is 135 degrees, or you can think about the fact that 45 degrees is 15 degrees away from the 60, so you add another 15 degrees. And then we're 30 degrees shy of 180, which would be 150 degrees, or again, you can add another 15 degrees. Reflecting that 30-degree angle again, 180 plus 30 is 210 degrees, plus another 15 degrees, plus another 15 degrees. Moving past the 270, we add another 30 degrees, plus 15, plus 15. So notice the patterns that are created with these degrees. Each angle that's first in the quadrant is 30 degrees away from the axis, and the degrees in the middle are 15 degrees away from one another. For radians, it's a matter of counting with your fractions. So we can start with the pi over 4. Every halfway is another pi over 4. So we went up to pi over 4 halfway between the two axes. Adding another pi over 4, we have 2 pi over 4 up at pi over 2, and that's in simplest form. Adding another pi over 4 halfway between, and then pi would be at 4 pi over 4. So then we would add another pi over 4 to get 5 pi over 4. 6 pi over 4 simplifies to 3 pi over 2, and then we have 7 pi over 4 in the fourth quadrant, and 8 pi over 4 would be back at the x-axis, or 2 pi. 60 is a multiple of 30, and pi over 3 is a multiple of pi over 6. So for these next radians, you can just count by multiples of pi over 6. You simply skip those 45 degrees that we already generated. So we have 1 pi over 6, 2 pi over 6 simplifies, 3 pi over 6 also simplifies, 4 pi over 6 would simplify to 2 pi over 3. 5 pi over 6 does not simplify. And 6 pi over 6 would be pi. Into the third quadrant, we would have 7 pi over 6. 8 pi over 6 simplifies to 4 pi over 3. 9 pi over 6 simplifies to that 3 pi over 2. 10 pi over 6 simplifies to 5 pi over 3, and then we would have 11 pi over 6. Again, notice all of these patterns. The radians that are closest to the x-axis are pi over 6s, and the radians that are closest to the y-axis are the pi over 3s. So you could also just count by the pi over 3s if you didn't want to think so hard about simplifying, and then finally fill in those pi over 6s. And the last thing we need to do is get those ordered pairs in the second, third, and fourth quadrants. And that's simply a matter of changing the sign. In the second quadrant, those x values are negative. Make sure you reflect it like a mirror image. So the one closest to the x-axis is root 3 over 2, 1/2. And then we would have negative root 2 over 2, positive root 2 over 2. And the one closer to the y-axis is negative 1/2 root 3 over 2. Again, flipping and reflecting into the third quadrant where both ordered pairs will be negative. We have negative root 3 over 2, negative 1/2, closest to the x-axis. The one in the middle, negative root 2 over 2, negative root 2 over 2. And the one closest to the y-axis, negative 1/2, root 3 over 2. Reflecting that one more time, the one closest to the y-axis, this time our x value is positive and our y value is negative. Root 2 over 2, negative root 2 over 2. And the one closest to the x-axis starts with root 3 over 2. And then we have the negative 1/2. Notice the patterns. If you memorize the first quadrant of the unit circle and you memorize these patterns, or you recognize the patterns, you can use those to generate the other three quadrants. If my version of the unit circle was a little sloppy for you, here is a hard printed copy with the same values that I just generated for you. In the next video, we'll take a look at using the unit circle to generate some values for those trig functions again.